A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly, kindly confirm. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep. Welcome to another session of climatology, where we shall be continuing from where we left off yesterday. So, yesterday, what is it that we studied? So, yesterday, basically, we took a look at the various different types of rainfall which occurs. What do we mean when we talk about cloudburst and hailstorm activities? What is fog, mist, and the types of fog that we encounter? Why is it that these kinds of fogs they happen? And also, we took a look at the different types of clouds covered as well. Then after that, we moved ahead and we studied about the air masses, the concept of source regions, how is it that the air masses are named, and what is the concept of source regions, those homogeneous areas from where the air ends up picking up its characteristics, its moisture and temperature characteristics. That is what we refer to as the source regions. And then we looked at the concept of fronts. So what are fronts? So whenever you have cold and warm air masses, when they meet with each other, there is a zone of difference or a zone of transition that is referred to as a front. Then we also looked at the different types of front. We have the stationary front, cold, warm, and occluded front. And we also took a look at the various different types of weather conditions which exist in all these types of fronts. We looked at what do we mean by cyclonic circulation and also anticyclonic circulation, what they are. So these are the factors that we had read about yesterday. Today we are going to look into the aspect of cyclones. We are going to look into the temperate cyclone, the tropical cyclone, their formation, and also El Nino and La Nina phenomena, how they are created, where they are created, and what is the impact that they have on the regions nearby. So all these are basically going to be a precursor when we study the Indian portion of climatology, that is Indian monsoon. So it is going to be a precursor to all of that, the things that we are going to talk about and study today. So let us initiate the discussion with the formation and the process of temperate cyclones. Now here, the name temperate cyclone gives you some idea about the region where it is to be found. Now, what is a temperate region? So, just to give you a brief idea about tropics, subtropics, temperate, polar, etc. So, when we talk about the region of equator, we do know that at 23.5 degree north and 23.5 degree south, we do have the presence of Tropic of Cancer and Tropic of Capricorn. Right? So these areas in between, they are referred to as the tropics. In between the Tropic of Cancer and the Tropic of Capricorn. Then, in between the tropics and the Arctic and the Antarctic region, that is what is referred to as the temperate zone. Temperate zone. Okay. So accordingly, when you hear about the term temperate cyclones or tropical cyclones, they give you an idea where are they formed, where is it that they come into existence. That is the aspect of the naming. Now, this is also sometimes referred to as extratropical cyclone. Extratropical means something formed beyond the tropics. So this is also what is referred to as extratropical cyclone. Extratropical. Okay, that is what it is also referred to as. Now, these extratropical cyclones, where are they created is a region that we have seen. So basically, mostly you will observe the existence and the creation of these cyclones in the region around 40° to 60° north and south latitudes. Right? In these latitudes, in both the hemispheres, you will experience these cyclones to be created. Now, cyclones are what? Cyclones, what we studied yesterday, are extreme low pressure regions, intense low pressure areas. Now, in these regions, in the temperate regions, you have the creation of these kind of cyclonic circulation, as you can see on the image as well. Now, these circulations, they are very, very large, very huge cyclonic circulations. They emerge around a low pressure region created in this area. Now, in this area, that low pressure is mostly created due to the occurrence and observance of a front. Whenever you have a front which is created, mostly it is the polar front. When that front is created, it is across that front that sometimes a low pressure is observed or is experienced. So because this low pressure is observed across a front, that is why this is also what is referred to as frontal cyclone. Frontal cyclone. Okay. Now, they are created when you have the creation of a front. So, for the creation of these cyclones, necessarily you need the existence of a front, a strong front. But does not mean that every front will develop into a kind of a cyclonic circulation. I will repeat. For the formation of these temperate cyclones, you necessarily require the existence of a strong front, but does not mean wherever there is a front in existence, it can develop into cyclones. Only under certain specific conditions will the front be developing into a cyclonic circulation in an area. So, here, existence of a front is necessary for development of low pressure circulations. Does not mean that all the fronts will develop into a cyclonic circulation. Only in certain cases can the fronts achieve that. Then here, it is formed whenever you have the formation of a front. It is in that area where, and it is in that circumstance where you will observe the formation of that low pressure. Now, front is created when you have a difference in temperature in between the cold air and the warm air. So, stronger the difference in temperature between the cold air and warm air, stronger will be the creation of a front as well. More frequently the front will be created, isn't it? If the difference in the temperature of cold and warm air is greater, more frequently the front will be created. So we can write this with a stronger difference in temperature between warm air, more frequent frontogenesis is observed. More frequent frontogenesis is observed whenever you have a greater difference in temperature, isn't it? Because after all, what is a front? Front is that zone of transition which indicates the difference in property of the air mass. So if let's say one air mass is very hot, the other air mass is very cold, So the difference, if it is stronger, obviously that zone of transition will be much more prominent as well. So that is when the front will be much more prominent, the front which is created. Now, in which season do you think there will be a greater difference of temperature in between the warm air and the cold air? The warm air coming from here and the cold air coming here. In which season of the year do you think there will be greater difference in temperature between the warm air and the cold air? Okay. So basically, let us examine it. Okay. Many of you have given the split answer. So many of you have basically given winter as answer and summer as answer as well. So let us analyze this. So here, when we consider winter temperatures, and summer temperature. Now, the cold air is brought from the polar region and warm air is brought from the tropical area. Right? So that is where we have to find out what is the difference in temperature in these months on an average. So we will get an idea that when is it that there is a greater difference of temperature. So during summer months, what is the temperature in the region of the poles? Roughly you will find around -5, -10 degrees Celsius, -15 degrees Celsius in certain cases. So let's assume on an average -15 degrees Celsius. Right? Now, the tropics during the summer season will have a temperature roughly around 30 degrees Celsius, right? Around 30, 35, 25, that is the range of temperature. So here, the temperature of 30 degrees Celsius. Now, during winter in the polar region, the temperature that you expect -40, -45, -50, up till that extent the temperature can go. Let us assume -40 degrees Celsius. Right? On an average, let us assume. Whereas in the tropics, when we talk about the winter, the temperature is around how much? 20, 15, 20, 22, 23, 25. That is the range of air in our air temperature. Let us assume 20 degrees Celsius. So what is the difference in air temperature during both seasons that you observe? In the case of the summer season, the difference comes out to be 45 degrees Celsius. Right? Whereas in the winter, the difference comes out to be 60 degrees Celsius. A delta of almost 15 degrees Celsius, which is huge, which is extraordinary. That is where you'll find that frontogenesis in itself is more common and more frequent during the winter season. So that is where we come across the fact that frontogenesis in itself more frequent during winters. Okay, it will be more frequent during the winter season. Now let's assume a cyclonic circulation has developed in this region. Or here, in any of these areas. We have seen that the probability of development is more frequent during the winter season because front development is more frequent during winter season. So the probability is that the cyclone will also end up developing during the winter season more frequently. But if a cyclone is formed, now that cyclonic disturbance that will be carried by the wind pattern as well. the permanent wind systems, they will be able to provide that push, some amount of push to that cyclonic circulation. So in which direction do you think the cyclone will move? Here, when we talk about the direction of movement, in which direction do you think the cyclones will move? What do you think? Is it going to be north to south? Is it going to be east to west, west to east, south to north? What do you think? Very good. It is going to be west to east. East. Why? Because in this region, we already observe the existence of the permanent wind system in the form of westerlies. You have the westerly winds, which are very prominent in this region. They are able to carry this storm, they are able to carry this cyclonic circulation in the eastward direction. So due to presence of westerlies. Presence of westerlies. So these are few of the features that you observe to be existent in the case of a temperate cyclone. These are formed across large areas or large fronts. So that is why the circulation which is achieved is also something which happens over a very large area. This cyclonic circulation, the cloud patterns and everything that you see, this can have a diameter ranging to almost up till 1,000 kilometers. From around 750 kilometers wide to almost 1,000 kilometers can be the entire diameter of this cyclonic circulation. So it is a very large atmospheric disturbance that happens. Now, the fronts here, yesterday, while taking a look at the different air masses, we also took a look at the fact that these fronts, are they created across a straight line or are they created across a wavy structure? What do you think? The frontal creation, is it observed across a straight line or across a wavy structure? Very good. It is something which is observed across the wavy structure. And why is that? Because if you take a look here, if I take you back and if you take a look at the air masses, you can basically observe that the air masses, the cold and the warm air masses, they are not separated across a straight line. They are separated across a wavy pattern. You have certain areas in which the warm air tries to sneak in and certain areas where the cold air intrudes into the warmer territory. Something similar is in existence even in the southern hemisphere. So that is where the front will not be in a straight line, it will be in a wavy pattern. That is why this temperate cyclone, because it is created over a front, it is also what is referred to as a wave cyclone. Wave cyclone. All these are the features and the phenomena that is associated in general with the conditions of a temperate cyclone here. So here, a temperate cyclone is also referred to as a mid-latitude depression, extratropical cyclone, frontal depression, or even a wave cyclone. Now, they are active above mid-latitudinal regions from around 35 to 40 degree north and south to about almost 60 degrees, sometimes 65 degrees north and south latitude. That is beyond the tropics. The tropics extend up till around 23.5 degree north and south. So beyond that, because the front formation will never happen in the tropics, it will always happen closer to the middle latitudes, isn't it? Because that is where you have the cold and the warm air masses which will meet. So that is why it is across those fronts that this depression will develop, it will intensify, and hence you have the formation of this temperate cyclone. Now, the direction of movement is from west to east due to westerlies. And this is more pronounced during the winter season. Why? Because the difference in temperature is higher. Difference in temperature is higher. Okay. So these are few of the features that you generally associate with. It is along these latitudes that the polar and the tropical air masses they meet and they lead to formation of a front. So let us analyze the entire process of formation. Let us try to understand how this is formed, why this will be created, and what are the weather conditions associated with it. So for understanding and for the purposes of understanding, we have divided the entire process of the formation into 5 various different stages. From the very initial stage, since the front gets created or formed, till the stage of dissipation of the cyclone, we have various different stages through which the cyclonic system ends up developing. So the first stage, in the first stage, again, I want you to always keep the larger picture in your mind. Larger picture in the sense, not the magnified one, but basically where it is happening across the planet and what is happening. So here, in the initial stage, you have the cold air from the poles, which are coming in. And simultaneously, you have warm air from the tropics, which are trying to go there. Now, in certain areas, it is the cold air which will be more active. In certain areas, it is the warm air which will be more active, right? Because we have seen the ideal conditions and the existent pressure zones where the circulation is driven from. We have seen that rather than an entire pressure belt, we have the presence or the existence of few pressure zones which are in presence. So that is why in certain areas, you have the warmer air which is further pushed into the colder region, and vice versa also happens. So the first stage, let's assume this place. Here, you observe the formation of a front. Initially, the cold air will reach there, the warm air will also reach there, right? Now, initially, when they are in front of each other, and neither the cold air is pushing into the warm region nor the warm air is pushing into the cold region, then you have the stationary front. This is the first stage where neither of them is pushing into each other's territory. So this is what we have initially as a stationary front. Now we have seen yesterday that when we talk about the stationary front, over a period of time, over the passage of time, what can happen here is that the warm air and the cold air, they mix with each other. Let's say none of the front moves, or neither the cold air moves nor the warm air moves. We have looked at it yesterday that over a period of time, it might happen that since none of them are moving, so at the boundary region, they start mixing with each other. They gain each other's properties as well, right? So that can always happen. So that is something which can lead to the death of the front there itself. But sometimes what can also happen is either the cold air starts advancing or the warm air starts advancing. Generally, you will find the creation of a scenario where in certain areas the cold air starts to advance, and in certain areas the warm air that starts to advance. So after this, in order for the creation of a temperate cyclone, you'll find cold air advances into the warmer region and warmer air advances into the colder area. So after this, cold air advances into warmer region and vice versa. So in that case, what will happen? Now, wherever the cold air is advancing, what kind of a front will be created across this area where the cold air is advancing? We will have the creation of cold front, isn't it? When the cold air is advancing, that is where we will have the existence of a cold front. And where the warm air is advancing, we'll observe the formation of a warm front. So after this, as the air starts to advance, you have the creation of two different simultaneous fronts very close by. So in this case, that is when we say beginning of a young adult of a cyclonic circulation. So in this, simultaneous formation of a cold front and a nearby warm front. Right? I hope we are fine up till here. There is not much of a concept to be understood till here. Till here it is plain and smooth sailing. Now let us try to understand few of the complexities which result thereby. And for this, again, I will take the help of the best environmental model, and that is the piece of paper. So I'll give you a scenario where there is a warm front which is getting created and warm front is advancing, and also a cold front. So begin with the cold front. Let's suppose here you have warm air and here you have the cold air. So as the cold front is created, it is advancing. We observe that the warm air is being pushed up vertically, right? Now, overall, can we not say in an area that the cold front leads to rise of air parcel, right? We can say cold front leads to rise of air. It is the warm air which is rising when you have the cold front. What happens when a warm front is created? In the case of warm front, suppose this is the region of the cold air and here you have the warm air. So when we say a warm front, so it is the warm air which advances. As the warm air advances, it keeps on climbing over the region of the cold air continuously, isn't it? That it starts climbing over the region of the front very easily and continuously. So we can say that in the case of warm air, even though the climb and the rate of rise is less, but nonetheless leads to a slow rise of air. Now after this, go back to the basics of air pressure. In any place where we have the air column which is sinking on the ground, what is the condition of pressure on the ground? When the air column is sinking, we observe what kind of effect? We experience high pressure, isn't it? Now the converse of it, in any place, due to any reason, thermal reason, due to dynamic reason, any reason, if you have the air column which is rising up quickly or slowly, regardless of the rate of rise, but if you have the rise of air column in any particular place, what will be the impact of pressure on the ground? You will have low pressure created. Now, because in a very close region from here also, the air is being vertically pushed up as the cold front is advancing. Here it is moving slowly, but nonetheless, in very close vicinity, because you have such significant rise of air in very close quarters, that is what creates an intense low pressure. This is where the entire cyclonic circulation is born. If this simultaneous cold and warm front would not have been created, this circulation would never have been achieved. But now that they have been created, this circulation is born. This circulation, intense low pressure is achieved, first of all. And let us see what happens. Once you have intense low pressure, that means what? Winds will come at it from all different directions, isn't it? Wherever you have a significant low pressure which is created, that means winds will be coming to that region from all different directions, isn't it? Now, here also, you will have the intense low pressure created here. You'll have the very intense low pressure at the region where you have the cold and the warm front. So this intense low pressure which is created means what? Means you will have more cold winds also attracted here and more warm winds also attracted here, right? So you have intense low pressure condition, intense low pressure, due to which you have more cold winds and more warm winds come in. And basically, cold winds, they are generated from where? From the polar area. Because of thermal high pressure belt, these cold winds are generated directly from the polar areas, the polar regions. And these cold winds, then they start moving. They stick closer to the ground surface and they start moving. And that is when, from the ground surface, regardless of whether it is a warm front or a cold front, regardless of that, during the mature phase of a cyclone, you will come across a scenario somewhat like this. Here, you will have the warm front, obviously. So there is a coloration pattern included of this as well, how a warm front is represented and how a cold front is represented. A warm front is generally represented by the red semicircles attached to the line of the front, whereas the cold front is indicated by the presence of blue triangles across the line of the front. Right? So you have cold front and you have a warm front. And here you have the intense low pressure. Right? Now, on the ground, let us take a look at the air which is present on the ground. Let us try to analyze this. See, for the general studies purposes, let me again tell you, for examination, you don't need to know this much in detail. Till now, if you take a look at the trend of the questions that UPSC has asked from temperate cyclone, all that you need to know that fronts in certain cases can develop into a cyclonic conditions. But you need to understand how it develops so that you are able to understand the weather conditions which are formed when this cyclone develops. Because the weather conditions formed in this cyclone is very different from the weather condition created during a tropical cyclone. So that is why it is always better to understand the basics of formation so that the difference which is asked in certain cases, that can easily be driven about. Now here you have, let us analyze the conditions of air in the ground. So let's consider three different regions, 1, 2, and 3. So in the region or in the position 1, do you think on the ground you will have the presence of cold air or warm air? What do you think? What will be the ground level, not upper air? Ground level, do you have the presence of cold or warm air? Very good. Most of you are absolutely correct. See, one that I am talking about this portion. 1, 2, and 3. Okay. So in 1, on the ground, you will have cold air. right? Warm front is advancing in this direction. So obviously you will have cold air on the ground. In the region 3, what do you have? Cold air is coming into the region 3 and it is moving further in this area. So in region 3, what is the condition on the ground? Very good. You have warm air. And here again, you have cold air. So that is the condition that you observe. Now from here, let us again stick to the basic principles that we know, and based upon only those basic principles, we'll be able to understand that. What is the basic principle we know? Whenever low pressure is there, immediately all the winds are attracted. The winds, when they reach the region of the low pressure, they will develop a kind of a circulation due to Coriolis force. That is also what we have seen, right? Now here in this low pressure, you will have cold winds which are attracted, right? You will have the cold winds in the region which will be attracted here from all different areas. And also, you will have warm winds also which will reach there from here. They will try to reach there at least, right? Now, as more cold winds come in, so this cold front sometimes can get a bit stronger as well. But nonetheless, all this air which is reaching the low pressure, this air will initiate a circulation in this entire region. And here you will find an upper air disturbance or an upper air circulation leading to the formation of clouds. This is where, as the winds rise up, they will develop a kind of a circulation, right? And that is what a cyclonic cloud formation will look like. But the weather pattern, it is not as if in the entirety of the region, the weather pattern will be consistent. For example, if I tell you that across this line of cold front, what will be the weather condition experienced? What will be the weather condition experienced here? Let me know. We do know that what is the weather condition experienced when you have cold front. So here you have, very good, beautiful. You have heavy rain with thunder and lightning. Because we will have cumulonimbus clouds getting created here. So in this region, you will have cumulonimbus clouds. Cumulonimbus clouds created there. Now, let us consider the region which is closer, not very far away. But here, you will have a very different conditions of temperature. So here, you will generally find nimbostratus and stratus types of clouds. Nimbostratus or stratus types of clouds. So as a result of that, the weather associated will be light rainfall, light but prolonged rain and continuous rainfall. Prolonged rains, isn't it? That is the kind of a condition that you will see, you will observe. What about the other areas, these areas where you have the cold air gripping up? Those areas, they will only experience heavy wind movement because the wind is moving towards that low pressure, but you won't experience significant amount of cyclonic disturbance there. You will experience some occasional rainfall here and there. If the winds coming from that to that region, they are bringing moisture, you can experience, but major weather events will be observed across both these frontal areas. Now, the cold air that will start advancing in the form of the cold front, The warm front will also advance, but as the warm front advances on the ground, what is the condition? On the ground, as the warm front advances, you will have the cold air on the ground, warm air keeps on rising up. So slowly and steadily, the situation which will be created is, take this case as the warm front. This is your warm front, right? And this is your cold front on the other end. Cold front slowly and steadily starts advancing. It gets closer. Warm air keeps on rising, and eventually the fronts will meet. Now, when the fronts will meet, then what happens? Whatever warm air was there on the ground earlier, if you have the warm front, the warm air is rising here, cold front, again, warm air is on the ground. But as the fronts will end up meeting, what will happen to the warm air? On the ground, there won't be any area of warm air anymore. All the warm air will be completely lifted up. So when on the ground, all the warm air is finally lifted up, isn't that going to lead to the closure of the front or the death of the front? Because on the ground surface, now you have only the existence of cold air. So that is the beginning of the end of the cyclone or the dissipation phase of cyclone. Let us take a look at it. So here, when we talk about it, the beginning of occlusion. Here observe that the cold air has, or cold front has started advancing. The warm front is created with the rising of the warm air. In both these areas, that is, here you have the advancing cold front. Advancing cold front. Here you have the warm front. And here you have the persistent low pressure. It is that low pressure which is attracting the winds from all different directions. Now, eventually, what do you observe in this case is that the cold air, the cold front, it starts to move forward. So it starts to close up to the region of the warm front, right? So here, the cold front starts to advance. Why? Because of extreme low pressure attracting more cold winds. They will attract warm winds as well, but cold winds, when they are coming in, they will advance the cold front. So here, this is where cold front begins to close in the warm front. Right? Now, when they close in, that is when you have the occlusion. Observe that this is where the front has been closed completely, right? So this is when the when we say the occlusion has happened, this is when the warm air is completely lifted off the ground, right? And occlusion leads to closure of the front, which is also referred to as frontolysis. Okay, so occlusion leads to closure of the front. That is what is going to lead to frontolysis, and that means the end of end of cyclone. Okay. So that is the entire journey of this temperate cyclone. Again, if I take you back to all the stages, let us analyze all the stages once again. This will serve as a quick revision point as well. So in the initial stage, you have the warm air and the cold air, which reach each other's region, but they are still not prodding into each other. So you have the initiation with the development of a stationary front. That stationary front can only, in certain cases, will it develop into a temperate cyclone. Otherwise, it will not develop into a temperate cyclone. So that stationary phase, in certain areas, you will observe that there is the cold air starts coming in into the warmer area, warm air starts coming in into the colder region. You will observe that. So that is when eventually in each of these cases it leads to the rise of air. You have the simultaneous, when the cold air comes in or the warm air goes and creates a warm front. In either of the cases, that leads to the rise of air, right? The air starts to rise up. Now, when the air starts to rise up on the ground surface, it will create a low pressure center. And that low pressure center will attract winds both in the colder region as well as from the warmer area. The winds will be attracted from both. Now, when the winds are attracted from the colder region, these winds, they won't go higher up. They will be mostly sticking to the ground surface as they move forward. The warm air, as they are attracted, they will be immediately lifted up because all around it, you have the cold air which will not allow the warm air to penetrate into the ground region. So warm air will be consistently rising up. So due to that rise up of the wind around that low pressure, you have that cyclonic disturbance which is created, and you have the simultaneous formation of a warm front as well as a cold front. Now, that is why in the case of a temperate cyclone, you have different weather conditions observed in different areas. Wherever you have the cold front, because of the violent vertical movement of the warm air, in those areas you experience heavy thunderstorms, heavy rainfall, lightning, because of the formation of cumulonimbus clouds. On the other hand, as the warm air starts advancing and is also attracted to this low pressure, but the warm air, it will not be pushing the cold air backwards. The warm air will keep on rising upwards, right? So because the cold air will provide that inclined plane across which warm air will rise easily. So across the warm front, you will have nimbostratus or stratus kinds of clouds which are created, which will lead to the light rainfall, prolonged rainfall, lack of significant thunderstorm or lightning event. So very closely, in very close quarters, they experience different conditions. Now, then eventually what happens? The cold air that is present on the ground. So here the low pressure is going to attract warm air as well, the cold air. Now, while the cold air as it comes, it will start pushing in and basically occupying more space on the ground region. Whereas the warm air as it comes in, it is directly lifted. So on the ground, the region which occupies that warm air, that starts to reduce on the ground. That starts to reduce because the cold front begins to close into the warm front. And eventually, the front is closed. That is the phase of occlusion or the occluded front, remember that we studied. So that occluded front gets created and it is the end of the cyclone. So the occluded front marks the last phase of the entire process of cyclone, which initiated from second stage to the fifth stage, which demarcates the last stage of the cyclonic circulation. Okay, so that is how you have the development of a temperate cyclone. Okay, can we say a cyclone is a combination of all the fronts? Sometimes you will not find the formation of a stationary front, Pratyaksh. Sometimes directly a combination of a cold and a warm front can lead to it. Roughly, Karthik, this entire process takes around 2 weeks. In its entire process, around 10 to 14 days. Majorly, low pressure will attract cold winds since warm air is rising consistently. Both of them will be attracted, both warm and cold air. On the ground, the cold air will occupy majority of the areas because it is a warm air which is consistently pushed up, Devansh. How cyclone ends, Monica, that is when the front ends. So that means around this low pressure area on the ground surface, you don't have any difference in temperature anymore. So the front will dissipate. So if the front is not there, why will the cyclone come into existence anymore? So that is the end of the cyclone. Okay. Which continents or areas usually get affected by this cyclone? Generally, you will find the impact being felt across both ends of the Atlantic and also in the region around Japan, sometimes around northern Pacific. So in those areas, even around the southern part of Australia, but mostly Europe, Atlantic and North America are impacted by this. Pranay, after occlusion, what happens? The weather normalizes in the sense that now you have only cold air. So now you don't have that rising convection cell. So there will be calm conditions which shall follow for a long period of time. Okay. Abhishek, it means temperate cyclone occurs due to cold advection and front formation and end of warm air led to the death of cyclone. Not only cold advection, there was a warm advection in place as well, Abhishek. If only cold air would have moved, maybe that intense low pressure would not have been created. Simultaneous occurrence of cold and warm front, that has intensified. So warm advection also. Nitesh, and alterations if occluded front, uh, alterations as in Nitesh, the weather conditions, if you are asking, the weather conditions wherever the front is coming to an end, the weather conditions will be significantly static and gentle without a lack of rainfall. Overall weather conditions in temperate cyclone, Ananya, basically overall you will observe the occurrence of rainfall in many areas depending upon the conditions, thunderstorm, lightning, etc. that will be observed. Strong wind movement, rainfall, etc. Yes, Sachin, that is correct. And Priyanka, low pressure means lake of warm air? Absolutely not, my dear friend. Absolutely not. Suraj, just because warm air completely rised up and we know that cold air doesn't rise, yes, in a way. See, front is what? Front is when you have the difference in temperature on the ground surface. So if there is no warm air on the ground surface, will you have the front anymore? No. If you don't have the front, will you have the frontal cyclone anymore? No. So that is why. It can occur across both land and oceans, by the way. Right? A warm front leads to creation of advection fog. Depends on the region. Depends on the region, Devansh. And how long cyclone is carried out, Sukanya? Basically, it is in existence for around 10 to 15 days overall. In which stage the cyclonic circulation is started? Sahil, towards the end of the second stage and the beginning of the third stage. That is when the entire circulation comes into existence. Aman, what decides the direction of the cyclone? The existence of the permanent wind systems in the region. They determine the direction of the cyclone. And right? Adeline, what creates cyclones? The intense low pressure. When you have extreme and intensified low pressure on the ground conditions, on the ground situation in such a way that it will attract winds from all areas and the winds will rise up around that low pressure. That is what creates cyclone. Over both land and sea, temperate cyclones will be formed over both land and sea. Okay, good. Now, here, is this the only way of origin and end of cyclone? For temperate, yes. For temperate, mostly you will find this is the way for origin and the end of the cyclone. If I am Rohan, if I am standing at the surface, then in which direction will be cold front and warm front respectively? See, Rohan, my dear friend, cold front and warm front, they change drastically. I will give you an example. I hope you don't get confused. Yes, Biswajit, mostly in temperate zones only. I'll give you an example, Rohan. So sometimes, let's say you are standing here as an individual. This is your equator. And the cold front and the warm front sometimes can be like this. In one region, it might not be in existence only, right? Maybe because the polar winds are very weak there. So in one region, no front. Then in another few weeks, you might find that the front is somewhat like this, or the front which is created is somewhat like this. So that is why the occurrence, if everything would have been the same, the cyclone would have always originated in the same place. But that is not the case. It keeps on changing. Okay. Yes, fronts can be intensified due to blizzard or any strong polar winds that you come across. It can lead to intensification of the front. Now here, sometimes what happens, this low pressure conditions that you see, it is these low pressure conditions which will attract the winds. It is those winds which will come in, which will bring the different types of rainfall, different amount of rainfall. This low pressure system sometimes intensifies all of a sudden, maybe because of prolonged heating of the ground surface, maybe because of sudden movement of cold air from the poles leading to further straight uprise of the warm air or uplift of warm air. So because of some factors, it has been found out that in certain cases, let's say the prediction is that the low pressure will be around 880 millibars by Tuesday or by next Wednesday. And suddenly you find that within 24 hours, that low pressure has intensified by more than 24 millibars. In that case, when the low pressure suddenly intensifies, the movement of the wind strengthens, the velocity of the wind becomes stronger, the rise of the wind also becomes stronger. So if the wind velocity becomes stronger, along with that, the rise of the wind also becomes stronger. What will be the impact on weather? More cumulonimbus clouds everywhere. In this case, the warm air will also start rising up so rapidly. Even in the region of warm front, you will observe some cumulonimbus clouds to be created. And whenever the winds, they rise up straight forward, and that too with a great intensity, it can always lead to hailstorms, significant thunderstorms, very strong thunderstorms. That is when, followed by a very strong movement and very stringently violent weather conditions, this cyclone becomes very destructive. And that happens when there is unexpected intensification of low pressure within 24 hours. That is what we refer to as a bomb cyclone. So bomb cyclone, when you hear about, it is nothing but a super intensified form of a temperate cyclone in most of the cases. An extremely super intensified form of a temperate cyclone. So here it is a powerful, rapidly intensifying storm associated with sudden and significant drop in atmospheric pressure. In case when the atmospheric pressure lowers by around 24 millibar or more within 1 day, if the low pressure gets more intense by 24 millibar, that will attract much more stronger winds. So this attracts much stronger winds, and along with that, and severe weather conditions. This is when, in the coastal areas, especially in the coastal areas, when you take a look, generally observed across the region of Atlantic. So in the coastal areas, this is the sea, for example, this is the land. Now the waves, they crash in. Many of the times these waves, they are brought in by the winds, right? So you have, under normal conditions, the winds, they come in, they take in the waves, and they move forward. Have you ever thought about it that across the world we talk about the height as sea level, mean sea level, that is used as a reference point? When we talk about the height of Everest, we say 8848 meter above sea level. When we talk about any particular region, there's this much height above sea level. Sea level is always maintained as a consistent point. Now, that is because around the sea uniformly, overall, you have a uniform application of atmospheric pressure. So, you have 1013 millibar of pressure which is consistently applied, right? Imagine in this area, there is a pressure reduction suddenly, and that pressure becomes 750 millibar. Sudden intensification has happened. Think about it carefully. In rest, all of the regions, more or less around 1013 millibar, 1010, 1020 is roughly around. In one area, suddenly it has become around 750, 780 millibar. What change will you observe? What do you think will be the change here? Will there be a change in the sea level? What do you think? Will the sea level change or will it not change? Good. Apply your general logic, guys. This is the sea. In all areas, you have an X amount of pressure which is applied. So that is keeping the sea level to some extent. In one area, a lesser pressure is applied. What will happen? Suddenly, the water level starts to rise up. So here, slight rise in water level, very slight rise in water level will be observed. Along with that, this has driven much stronger winds. Winds are very, very strong. So the large waves which will be generated, which we refer to as a storm surge, along with the slightly risen up water level, this will immediately lead to coastal flooding. Coastal flooding. That is why, even when you have cyclones developing in India, especially the tropical cyclones, it is issued, a warning is issued, please don't venture out into the sea. Why? Because the waves which are created, they become absolutely destructive, because not only is the sea level variable in those areas, but along with that, the strong wind movement drives water inwards, especially across river channels. You will observe a lot of flooding, especially across the river channels. And why is that? Think about it. Why we observe flooding across river channels? So when we say a coastal area or a coastal territory, let's suppose this is sea, this is river which is draining into it. Ideally, the river would continue to drain in the sea. What if the level rises ever so slightly, and this is further exaggerated by the wind? So the river water, will it find an exit point? The exit which was supposed to happen, there the level has risen up. So what will happen? The river water, for a brief duration, will not be able to empty into the sea. So the river channel will start to flood. The river channel will start to have more water. And eventually, all that water will spill over. That is why, in the case of these cyclones, when they are created or when they move from land to water, in the case of temperate cyclone, they bring about tremendous amount of coastal flooding, and flooding of all those areas which are across the river channels in general. Okay. Now, what is it that is not understood here, Pranay? Rivers. Okay. Think about it. Suppose, think about the river system. Take an example in your normal life, right? Why that sudden reduction in pressure takes place, Biswajit? It is dependent on many factors. It might be dependent on the factor that you have the high pressure in the poles, which is driving that cold air. Maybe more cold air is driven suddenly, due to which massive rate of uplifting is observed. Maybe there is intense heating on the ground surface. Any of these factors can lead to sudden lowering of the low pressure. Now here, when we talk about it, about the rivers, think about it. So here, imagine a scenario. Take a building. Now think about the parking of the building, the parkings that you have. So generally from the parking, you get to the road, isn't it? From the parking, you drive your vehicle and you move to the road. Given that the road is mostly at the same level or the building is at a higher level, due to some or the other instance, if the road level suddenly increases, will you be able to take your cycle or your bicycle or your car to the road now? No, because that level has been uplifted. Similarly, when we talk about the rivers, they are draining the water into the sea. And in the final portion, in the last stage of the river, the level is almost up till the sea level. Now there, as they are draining into the sea water, if it rises, what will happen? Will the river be able to empty its water into the sea? No, there will be a reverse back. So wherever the river channel has been, the river water starts to exit it, or river water starts to flood the banks because it cannot drain into the sea. So this will continue as long as there is a significant low pressure here. As this low pressure disappears, then again the normal process will be continued, isn't it? Right. And due to any example of this kind of river flooding due to temperate cycle? Yes, almost on an yearly basis, especially in the region around UK, Britain. You always end up observing this, Neil. Okay. And by the way, if you are uncomfortable with this idea of, or this portion of coastal flooding, ignore it, don't worry. You don't need to go into so much of depth. Just the basic of it will also suffice. Okay. If you have this aspect of pressure inducing a change in sea level, if that is slightly disconcerting, don't worry. This is not something which is going to be asked significantly in the exam. Bomb cyclone, in simple words, basically is the sudden intensification of the cyclone. That is it. Sudden intensification of cyclone, that is bomb cyclone. And the process of sudden intensification, that is referred to as bombogenesis or explosive cyclogenesis. That is what we have as the bomb cyclone. Okay. Now we come to the portion of, does bomb cyclone always form in the sea, Deepika? Not necessary. It is not necessary. Ram, yes. Tornado, Mupkalwar, is tornado formation linked to fronts? No, but there is a pressure gradient which is created vertically as well. So you have cold air, warm air, like that, and also you have the distinction of warm air coming from one region, cold air, but it is not a frontal creation. Okay. Any specific differences in cyclones developing over land or ocean? See, it is the temperate cyclone which develops over the both land and sea. Tropical cyclone will develop only over water body. Tropical cyclone will never develop over land. Arindam, have you understood the topic in entirety? And answer honestly. Will you be able to explain it to someone? Why is it that a temperate cyclone is created, where it is created, how it is created? Then how do you expect the subject to come to you? If you have not understood, then how is it that the subject is going to come to you? So you have to understand where, you have to first of all be able to pinpoint where you have not understood, isn't it? Otherwise, already we are going so slow. If we spend more time repeating this entire concept again and again, I don't think we'll be able to finish the portion at all. So, first of all, please understand that where is it or which portion, and this is something I tell to everyone. Any portion that you have not understood, the worst thing that you can do is repeat the entire thing again. That means you are not able to understand which is the hard portions. Try to pinpoint that figure. Mostly you will find that you are faltering in the basics. The basic portion would be inaccurate. Maybe the high pressure, low pressure, maybe the impact of temperature on pressure, maybe the intense circulation due to low pressure. It is those basics that people falter. But when they try to talk about the cyclones and the jet streams, etc., obviously it will never come into the mind. So get your basics in place, then this will all make sense. Otherwise, it will appear as if somebody is talking Greek and Latin. Few of the words you catch here in between, and that is all that the subject is going to be. So please, right now, here we talk about the tropical cyclones. So tropical cyclones are the circulations or the cyclones that we experience in India. These are much more devastating than the temperate cyclones. Even though there is, this coverage is over a very small area as compared to a temperate cyclone. This is observed over a very small area, but still it is much more devastating. This cyclone obviously will be formed in the tropics. So, by the way, it is not to be formed around the region of equator. Why? Because at equator you don't have the presence of Coriolis force. So this cyclone not to be formed around the region of equator. Around equator. Right? So general area where they will be formed will be where? Around 5 degree north to around 23 degree north, 25 degree north, and 5 to 8 degrees south to 25, 28 degrees south in both the hemispheres. That is the region where they are formed. So they are formed around tropics. Formed around the tropics. Right? Now here, the formation process is very different from that of a temperate cyclone. Here, this is something which is always to be formed around above water bodies only. So it is formed only above water bodies. Only formed above water bodies. Always. Okay. It is never formed over the land area. Why? We'll take a look into it when we take a look at the formation, only to be formed over water bodies and not over land areas. Now, these tropical cyclone, because they are formed in the tropics, they will also be influenced by the wind movement. So, the direction of movement in general, direction of movement will be in what direction here? What will be the direction of movement? Very good, Pranay. Ananya, very good. It will be west to east. Yes, Pratyaksh, more or less, but the direction is going to be generally from west to east, isn't it? West to east. Due to what? due to the presence of the trade winds in the region. Trade winds in the region, right? So that is where the entire cyclonic circulation is going to move about. Now, in the tropical waters across the globe, you have the formation of these cyclonic systems. Mostly, it is the shifting of the ITCZ which creates this ideal low pressure condition on the ground. We have seen, remember ITCZ that we studied in the tricellular model of circulation. Remember where we saw that you have distinct low pressure, distinct high pressure. So ITCZ is a distinct low pressure, and we saw that ITCZ shifts as well. Now, when the ITCZ shifts, let's say the ITCZ is here. So the low pressure systems can get created here. So whenever this low ITCZ lies over any water body, that creates ample condition for the formation of a cyclone here. But it will only form over water body. It will never be created over land area. And there's a reason for that. But then these cyclones, they are named differently in different parts of the world. The cyclone, it is not something that only India experiences. You have the occurrence of these conditions around the coastline of Atlantic, tropical Atlantic, and the eastern tropical Pacific Ocean as well. That is across the coastlines of North America. That is where this phenomena is referred to as a hurricane. Across the region of South China Sea, some parts of South Japan, China, in that area, this phenomena is referred to as a typhoon. In the region of North Australia, this phenomena is referred to as Willy Willy. In the region of Bay of Bengal and Arabian Sea, we refer to it as a cyclone, right? So these are basically referred to as cyclones in Indian Ocean, hurricanes in the Atlantic, typhoon in the Western Pacific, South China Sea, and Willy Willies. Okay. East to west. Okay, thank you for correcting us. So this is what they are referred to as. So that is their naming in different parts of the world. Now, not all the low pressure gets converted into a cyclone. Only in certain cases and in certain pre-existing condition will that low pressure get converted into a tropical cyclone. But then for that, we need to understand the formation, the process. And before understanding the process, I want to ask you one basic thing, a basic thing that you might have studied in your science class, but might not have. So, how many of us are not aware about latent heat? How many of us are not aware about latent heat of condensation? Okay. Yes, Ayushman, that is correct. Latent heat is the heat which is taken in or is given out when the substance or the material changes state, right? For example, when ice gets converted, and for this you have a simple experiment, and okay, fair enough. So here, let's assume you have a beaker, and in that beaker, you have completely filled it with ice particles, ice blocks. And ice cubes. Okay. And let's assume here you have basically installed a thermometer. You have installed a thermometer to measure the change in temperature, and you are applying heat. All those who have no clue about latent heat, kindly pay attention, because understanding this basic portion of science is very important for understanding the entire concept of cyclone. And this is something that I always say, that even the most complex of the topics, the understanding is always driven by one basic factor, maybe the rise of the wind, maybe why the wind rises. So these basic factors, if you understand, the most complex of the topics could be easily understood. So here, let's say this is getting heated up and you chart it out, right? You chart out the temperature and the heat given. I hope we understand that heat and temperature are not the same thing, right? Now here, initially, when you start applying heat, the temperature will indicate a rise. The temperature will indicate a rise with the increase in heat. At around 0 degrees Celsius, it will take in more heat, but the temperature will not rise. In that extra heat that is consumed, that heat will be consumed by this for breaking the bonds of the solid and getting converted into liquid. So this will be consumed to change the state of matter from solid to liquid. And then again, when it becomes completely liquid at around 2-3 degrees Celsius, again you apply heat, its temperature will keep on rising. Again, when it reaches around 100 degrees Celsius, even if you apply heat, the temperature will not rise. Why? Because that heat will be consumed for breaking the bonds with the liquid and getting converted into gas. So then you have vapor, and again steam. You heat it up, temperature will be rising. So this is what is referred to as latent heat. Okay. So whenever the material changes state, either it consumes or releases heat, which is utilized for the change of state without a change in temperature, that is latent heat. Whenever, I will repeat this, whenever a material changes state without a change in temperature, at that point of time, because at 0 degrees Celsius water can also exist, at 0 degrees Celsius ice can also exist. So whenever a material changes state, it either consumes heat or gives out heat for the breaking of the bonds or the making of the new bonds. That is latent heat. So this is what is latent heat. Now what is latent heat of condensation? So when you have vapor, when vapor changes its state from gas to liquid, it releases some heat. That heat which is released is latent heat of condensation. Whenever there is condensation which is happening, means vapor is changing into either liquid or into solid, right? So whenever it changes from gas to liquid or gas to directly solid, it will release heat for the change of state, and that is the release of latent heat of condensation. So whenever you have gas to solid or gas to liquid, it releases latent heat is released. Always latent heat is released. Okay, this is the basic of the sciences. Basically, wherever, in whichever chapter you would have read about specific heat, guys, you would have read about specific heat, etc. So in that chapter only you would have read about latent heat as well. So if you want to go back and look at it again, you can. Or in the tablet, in the portion of the basics in climatology, if you have seen the tablet till now, in the portion of the climatology basics, we have covered all of this heating and cooling in detail. So you can take a look from there as well. Okay, so that is what is latent heat. Okay, now that is what we talk about as the latent heat. It is a very essential part in the entire process of the formation and germination of a tropical cyclone overall. Now, this cyclone is named differently in different parts of the world. Now, not all the low pressure in this area will convert itself into a cyclone, not all the low pressure. Only in certain conditions, if the conditions satisfy all the parameters, only then a cyclonic circulation is generated. Now, here we will talk about another term, basic term, that is vertical wind speed or wind shear, as it is referred to. So we know that the wind speed at near the ground surface and the upper elevation, let's say V1 and V2, we know that V1 will not be equal to V2. Why? Because near the ground surface you experience friction as well. Higher up you don't experience friction. So always, in general, V1 will be greater than V2 because of lack of frictional force. Lack of frictional force. Isn't it? Because of significant lack of frictional force. Now, let's suppose you have the condition where V1, let's say, is 150 kilometer per hour and V2 is only 50 kilometer per hour. Now, in that situation, if near the ground surface there is rising up of wind and there you have the formation of a cloud system, but if the upper wind velocity is very fast, all that cloud system will be immediately carried away. It will dissipate, it will disappear, isn't it? All that wind will be immediately carried away. So for the cyclonic system to be persistent and to be developed significantly, you need very little difference of wind velocities. So for the cyclonic disturbance to sustain the wind velocity that is V1 and V2 need to be similar. Right? Otherwise, the clouds will get taken away and the system will dissipate. So when you talk about vertical wind speed, there has to be little difference, or we are considering horizontal here only, but vertically moving upwards or downwards, there has to be little difference of the wind experienced at various verticalities, right? If the wind velocity at the ground level and upper level, they are almost similar, then the system can grow, the system can develop. Okay, Suparno, the content of live class and recorded are same. No, they are not the similar. In recorded, we have put in certain areas which are more in live classes. The portions of relevance of current affairs we have discussed more. So it is different. Now, as I told you, that for the formation of a tropical cyclone, you need certain conditions to be fulfilled. So, what are those conditions? First, a large sea surface with a temperature higher than 27 degrees Celsius. That is a must. A large sea surface, right? That is a must. Generally, in certain cases, the Arabian Sea, Bay of Bengal, when you see a lot of cyclones happening there, they end up gaining a temperature close to around 30, 32 degrees Celsius even. That is when you observe a lot of cyclonic development. So, large sea surface with temperature higher than 27 degree, presence of a Coriolis force. It is a necessary condition to achieve a circulation. If the Coriolis force is not there, you will have winds coming in, rising up, causing rainfall, but you will not have a cyclonic circulation. That is why no cyclones at equator. Hence, no cyclone at equator. Very small variation in vertical wind speed, right? At various different levels, the velocity of the wind need to be similar at various altitudes. Wind velocity needs to be similar. A pre-existing weak low pressure area. So already in an area of water body, if let's say there is a low pressure, on top of that, if that region is intensely heated, so that the temperature increases to around 27 degrees Celsius or more, that is when a cyclonic disturbance is resulted. Let us take a look at the process of formation. Okay, let us take a look at the process of formation. Once you understand this process, please pay attention here. Once you understand the proper process, how this cyclone is created, that is all that you need to know. And that is something you will always find it to be inadequate in the various different books. In all the reference books that you will see, you will find that some or the other factor of that cyclone is given and you are unable to draw the complete picture. So that is why pay attention here, understand the concept and be done with it. So start with the ground surface. Okay, is it? Okay, so let's take a break, guys, and let's be back then after 15 minutes then. So after that we will talk about the formation. So we'll take a break. We'll be back by 6:50. Okay, we'll see, Suraj. Mostly we'll be able to finish. See, these are the conceptual areas where we take a lot of time. Indian geography, mostly theoretical. It should not take that much amount of time. Last slide, please. Okay, Satya, this is the last slide. Let me write here then as well. A confirmation regarding the audio, please, guys. If you are able to hear me out, thank you. So now we take a look at the process of formation of these tropical cyclones, how they are formed. By the way, how many of you here, you are not getting time to revise what we are covering on a daily basis? How many of us present here, be honest in it, okay? Anyways, I can figure it out by the questions that are asked. How many of you are not getting enough time to revise what has been discussed? Okay. Sahil, even that is enough, I guess. Okay. See, for all of you, I would suggest that if you are finding it very difficult on a day-to-day basis to revise, maybe because you have other commitments, you have other time commitments which are present, after the class, allocate at least half an hour, right? See, if you are holding off revision that once the entire thing is completed, then I will revise, it will take more time for you guys to revise. If you are doing it on a daily basis, you will take a lot less amount of time to revise. So do it on a daily basis. Not only will the understanding of the next module be very easy, at the same time, your burden will be lesser. See, you are already investing around 3.5 hours in this session. So revising those in certain cases can take 4 to 5 hours per unit if you have not taken up the revision in the 10 days to 15 days time period. So ideally, if you want to lower your burden, lessen your burden, from today itself initiate it. After the session, start with the PPTs, even the blank PPTs that you have. Don't wait for the annotations to come in. The blank PPTs that you have, look at each and every slide, look at each and every topic. Are you able to discern what has been taught there? Are you able to figure out that what do we mean by cold front, warm front, etc., when you open up the slide later? So that amount of very little amount of work also can give you very rich dividends. So I would always encourage you to go for this basic revision. And those who are revising, the result is very apparent. For you guys, it might not be apparent enough, but it is very apparent in the types of questions which are framed, the questions, the doubts that you have, and also your level of understanding. That also is very discernible just by looking at the question. So we get an idea whether you are revising or not. And this is not a typical subject where if you leave for 3 to 4 sessions and immediately in the fifth session you start following, you'll follow everything. It will happen in the portion of Indian geography where most of it will be independent of the earlier read portion. But still, it is something which needs to be done on a daily basis, guys. Okay. And right. So, see, Priya, in case you are in situations when you are not feeling well, fair enough. Those days will come. You have to make it up for for those lost days by extra amount of hard work. And Gagan, for the previous subjects that are covered, again, see, that is how you have to chart out your strategy. If you are revising on a daily basis, what I would recommend to you is that on 1 week, every day half an hour you have revised, then pick up a Saturday, the Saturday which is following, for example, tomorrow, for example, if you have revised on a daily basis, it will take you around couple of hours, and the entire thing which has been read and taught in the last week, that will easily be covered. Then you will have time, give 2 to 3 hours to the previous lectures that you have attended, and start putting it up and start revising that. Otherwise, just attending the classes, my dear friends, just sitting in the classes, that will not always give you that amount of dividend that you are seeking for. Okay. Next week, Biswajit. And Neil, best time to start is today, always. So let us take a look at the formation of it. How is it that this cyclone gets created? So as we said, you need the presence of a large water body, large sea surfaces in general. Now, due to the presence of a weak pre-existent low pressure and due to heating as well, in many of the cases, in certain smaller areas, you have the development of low pressure due to intense heating. Now, when you have that development of an intense low pressure over an area, what happens? This will attract winds from all directions. Now, winds will be attracted from all directions. Now, these winds which are attracted, this is also a kind of an air mass. What can we say about the characteristic of this particular wind? Can we not say that this particular wind, because it is in tropical region, this wind is warm and high amount of moisture? High amount of moisture is present. We are talking about tropical waters. So wind will be slightly warmer and high amount of moisture. Now, I'll take you back a couple of classes. We discussed about condensation. And there we discussed that when the wind is or when the air is moist and it is warm, even a slightest amount of cooling can initiate condensation. Isn't it? We had taken a look at it that if the moisture content is high, that air will reach saturation quickly, and that is where condensation can also happen very quickly, right? Now, here, as the air comes in, it spends some time over this low pressure, and this air, because this is a heated region, this air will also get warmer. As the air gets warmer, it will rise up. But will it rise in a straight path? Or will it rise in a spiral path? What do you think? Will the air, when it reaches air, will it rise in a straight path or will it rise in a spiral path? Obviously, a spiral path, because Coriolis force is at play. So that is when the winds, they start rising up in a spiral path. They start exhibiting a kind of a spiral rise. Now, all around this region, as the wind is rising in a kind of a spiral path all around this region, the wind will continue to lose its temperature. Isn't it? As the wind is rising, it will lose the temperature. This wind which is rising up, it will be losing temperature. The air will reach saturation. It is rising up, so the air will start condensing. Now, this is where the wind is moving. If I give you an option here that after reaching saturation, as the wind rises up, it undergoes condensation, where will the condensation happen? Will the condensation happen here where the path of the wind lies, let's say A? Or will the condensation happen in between, that is B? Where do you think condensation will happen? Where the wind is rising in that path itself or in between? What do you think? Beautiful. It will happen in the path of the wind. Where the wind is rising up, that is what will cool down. That is what will reach saturation, and that is what will start condensing. So always that condensation will happen in the path of the wind. So as the wind continues to rise further, condensation will be initiated on the sides, all around the spiral. If you imagine the three-dimensional, all around the spiral, the cloud will start to develop. So you will have condensation which will happen. On the sides. If you have to look at how the clouds are formed or what is the shape of the clouds that is represented in the image, I would take you to this image. This is the spiral in between where there is a lack of cloud. All around it, from all sides, you observe that there is a cloud formation which is observed. Now here, condensation is happening on the sides. We have seen whenever condensation happens, condensation leads to release of heat. Condensation leads to release of heat. Which heat are we talking about? Latent heat of condensation. Latent heat of condensation, isn't it? Now here, the condensation is happening around the sides, right? This is where the condensation is happening. Now, when the condensation is happening here, it will release heat. Where? Heat will be released here. Wherever the condensation is happening, there the heat will be released. In this region, isn't it? So the yellow or the red arrow represents release of heat. So what will be the temperature in the central portion? All around it, there is condensation which is happening, which is releasing the heat. There is circulation which is happening, which is releasing the heat. So what can we say about the temperature in the central area? The temperature, will it rise up? Will it fall down? Will it remain the same? What do you think? The temperature will increase. So in this area, let's say B, or let's name this region as A. In the region of A, we can say temperature rises up. Excuse me. Because of this factor, temperature will rise up. Now, as the temperature rises up in the central portion, will you observe any further amount of cloud formation in the central portion? Because for cloud formation, you need lowering of temperature. But here we see that at A, the temperature is further increased. So will we observe any cloud formation at A? No. So we can say that this is a region which is devoid of cloud cover. Devoid of cloud cover. Why? Because there is higher temperature. Fair enough. Up till this point, I hope it is clear. Now let us understand the intricacies of this air movement. Now for this, how the air starts behaving as a fluid and fluid movement in general. Air also tends to flow from one region to another. So many of the characteristics exhibited by air is very similar to the fluid dynamics in general. So here I would take you to a kind of a playful experiment that I'm sure most of you would have done in your younger days. If you do it till today, well, nobody can blame you. So here, I hope you would have seen a bucket with water. And if you have not given it a spin, have you ever tried to give that water which is present in the bucket? Have you ever tried to give it a spin? Create your own local whirlpool there. You have whirlpools in oceans, etc. But this is a whirlpool in the bucket. I'm sure most of you would have done that, right? Now, when you do that, when you induce that kind of a circular motion, if all those people who have not done this till now, it is high time in your life that you see these kinds of basic things in your life as well. So no offense meant, but you should try this out sometime. So when you ever rotate or try to induce that kind of a rotation, what happens to the water level on the sides? Does it go up? Does it fall down? Or does it remain at the same level? What happens? It rises up, isn't it? Water develops a kind of a circular motion. On the sides, it rises up in general. But what about the central portion? What happens to the water level at the central portion? Will it remain the same? Will it also rise up, or will it fall down? What do you think? It falls down, right? So you have a kind of a circular motion where the sides, they are rotating, and more vigorously that you induce that rotation, greater will be that circulation where the sides will simply go up and the bottom portion will sink down. If you increase the speed of rotation, the bottom portion will sink down further. All of us would have tried that. Something very similar happens here as well. How? So in that particular section where the air is getting risen up and undergoing condensation, imagine the air in that region to induce this kind of a circular motion. Now, when that circular motion is induced, on the sides, the air will start rising even further up, right? So as the air starts further rising up, you will have further development of clouds, right? But then what happens to the central portion? The central portion falls down. The central portion is pulled down. So here again, the central portion, this undergoes a sinking. So central portion of air sinks to the bottom. Now this air section, which was present in the center, we have seen that it is already warmed up, it is heated up. Now when this central portion starts to sink down, will there be any change in its temperature? Will the temperature go down? Will the temperature rise up? Or will there be no change in temperature? What do you think? What will happen as the central portion of the air sinks to the bottom? Very good. The temperature of the air column will further increase, further heating up. Due to what? Due to adiabatic compression. Adiabatic compression. Now this heated air further gets in contact with the water surface. And when this heated air gets in contact or touches the water surface, it is a heated air. So what will it lead to in terms of the impact on low pressure? It will further intensify the low pressure. So this further intensifies the low pressure. Intensifies the low pressure. Now the low pressure has been intensified. Means what? It will attract more winds. All these winds which will be attracted will be moist, will be warm because it is over a water body. So more winds will come in, right? So more winds come in. Come in and rises up. Intensifies means to get stronger, become stronger. So more winds come in and more winds will rise up, right? Because as more winds will come in towards that low pressure, they will also get heated up due to higher temperature. They will also start rising up. Now, when more winds rise up, there will be greater condensation. Greater condensation. Isn't it? Because more moisture is being carried with the winds. When there is a greater condensation which will happen, what does that lead to? More latent heat will be released, isn't it? More release of latent heat. Latent heat. And more release of latent heat basically leads to central portion of air eventually sinking to the bottom, further intensifying the low pressure. And this completes a cycle. So this will keep on repeating itself. And the cyclone will continue to get stronger and stronger. This is where a tropical cyclone is able to sustain itself. As long as it is above a water body, tropical cyclone is able to not only sustain itself, but also to make itself much more stronger over a period of time. And that is why you will see that the cyclones which have remained over water body, let's say for 1 week, they will be much more stronger. In the case of tropical cyclone, not the temperate cyclone, tropical cyclone, it is able to generate heat on its own. Why? Because of the sinking air and intensification of low pressure, it is able to regenerate heat in that system on its own. Now, when it is able to generate heat on its own, that is why this system of formation or generation, that is also referred to as a heat engine. Because it is able to generate heat on its own, sustain itself on its own without any external influence. Now, for the entire aspect of its sustenance, the presence of this latent heat is very important. If that latent heat, the release of latent heat, that does not come into the picture, or that is taken out of the equation, this entire cycle will break immediately, isn't it? Now, this latent heat will be present as long as there is cloud formation, as long as there is condensation, there will be latent heat. But condensation will happen when you have moist winds coming in a region. If you have dry winds coming in a region, there will be no condensation. As long as you have moist winds coming in a region, there will be significant amount of condensation. Fair enough? Now, where is it that you find the presence of moist winds? Over land areas or over water bodies? Over water bodies. That is why tropical cyclones, they will always get formed only over water bodies. Because if it is formed over a land area, the air which will be attracted to that low pressure will be dry. There will be no further condensation and no latent heat. So there will be no such sustenance of a cyclonic disturbance. It is because it is above a water body, it will continue to attract winds, warm winds that will feed into the system, that will continue to rise up and create that entire self-feeding mechanism. Okay, so eventually that is how you have the formation of a tropical cyclone. Now, when is it that this dissipates? How is it that this entire system will come to an end? Because as long as it is above a water body, it will keep on getting stronger and stronger. When does this entire process end? It ends when this entire system makes contact with the land, what is also referred to as landfall. Landfall of the cyclone is when the system comes over the land area. Now here, if you observe the entire cyclonic formation, you will observe that all around it, all around the sides, you have the presence of cloud cover. It is in the central portion that there is no cloud cover. This is also what is referred to as eye of the cyclone. No cloud cover. Okay, no cloud cover in the eye of the cyclone. So here, an area which is exposed to the eye of the cyclone, they will experience clear skies. They will be able to see the sun as well. They will experience calm conditions. Why? Because there you have the sinking air. So in the eye of the cyclone, you have column of sinking air. Right? Now let us see what happens when this cyclonic system makes a landfall. It comes over a land. Let us understand that. So first of all, it will be the sides of the entire cloud cover. That side will reach the land. Now these are cumulonimbus clouds. So when they may reach the land, they will cause rainfall, significant amount of rainfall. Then you will have the eye wall. These are what are referred, these thick portions, they are referred to as eye wall. And this is what is referred to as the eye. Okay. So across the eye wall, once the eye wall comes and makes contact with the ground, very heavy thunderstorms, very significant and vicious lightning strikes, and very violent rain. And it will cause a lot of destruction and damage. Then the eye will make contact with the land. When the eye makes contact with the land, the scenario suddenly opens up. The skies become clear and calm, and everything is, it appears as if the cyclone has dissipated. But the cyclone has not dissipated. After the eye makes the landfall, the portion on the behind, that is this portion, this then makes the landfall. So immediately, this is where a lot of lives are lost. When people see that it is a clear sky, they feel that the cyclone has passed by. So rather than taking precautions, they immediately start venturing out, they start roaming outside, and they start carrying out with their regular work. But then that is where the second part of the eye wall strikes. That again brings huge amount of rainfall, violent thunderstorms, lightning events, and eventually that is when we say that the cyclone has come over land. Now that is when the low pressure has come over the land area. So it will continue to attract winds, but those winds won't be moist. So that is when the this entire cycle of heat engine will be broken, and slowly and steadily the cyclone will start dissipating. Okay, so to recap it all, the entire process of formation, if you observe the entire process of formation, it starts with the development of low pressure over a water body, which attracts winds. The winds rise up, there is condensation, formation of clouds that will emit latent heat of condensation, which will accumulate in the central portion. The clouds will start growing across the spiral on all sides. And basically that heat which is present in the center, that means no cloud at the eye. And moreover, in the central portion, you have subsiding wind or sinking wind, which further intensifies the low pressure on the sea surface. That attracts more winds, more will rise up, more condensation. Condensation will always happen across the central area, and the clouds will get pushed to the sides. And these are very thick cumulonimbus clouds. It will continue to arm itself and continue to become stronger and stronger by the day, as long as it is above a water body. The moment it comes over a land area, that is when the cyclone will lose its intensity, because its contact with the moisture source goes away. Okay, right? Pratyaksh, it will cause rainfall there. Sahil, tornado and cyclone is the same? No. Why does a clear sky happen in intermediate state of tropical cyclone hitting land? Because over the region of the eye, you don't have any cloud cover. So if, let's say, you are standing here and you look at the eye, then obviously, and the eye is above you, so obviously you will have clear skies. Over oceans, low pressure is created during nights? No. See, this low pressure is not the seasonal low pressure or the daily low pressure, high pressure created. This is not something which happens in the coastal area. This generally happens away from the coast, and that is due to increased heating and the presence of low pressure belt such as ITCZ, which passes through that area, that further intensifies the low pressure. Okay. We discussed the direction of movement of cyclones as east to west. Then how come we saw cyclones on the west coast last year? We'll come to it, don't worry. When we come to Indian portion and we come to the movement of ITCZ, it is still driven by the permanent wind system, and trade winds are the ones which drive the cyclones. But once we study the movement of ITCZ above India, all this will be very clear. How heat is produced in between what, Priyanka? Ampan was a cyclone which struck West Bengal, Arindam in 2020, April 2020. We are in 2023 as of now. When does the cyclone finally dissipate? When the eye comes over the land, Vaishna. Why does hot air of ice sink down rather than rising up, Abhishek? As I told you, because of the circular motion induced, there is a suction which is present or induced in the central portion. That is where we had the bucket example as well. When you create a circular motion on the sides of the bucket, the central portion sinks down. Yes, Ananya, that is true. Temperature of eye is much more than the eye wall. Hurricane is very similar to a tropical cyclone, Monica. It is just named differently. If at all no land present near clouds, then how landfall will occur? Amit, eventually you will have the winds, they will carry the planetary winds, they will carry it to some shore or the other, some coastline or the other. Vishwa, how will the cyclone come from sea to land? With the help of the permanent wind. Will the cloud come down? No. Why will the cloud come down, Vijay? Okay, Bimal, regarding the sinking warm air. So again, for those who have missed it out, the bucket example, take a bucket, fill it up with water up till some level, start rotating it in a circular motion. You will observe that on the sides, the water level starts to increase. But in the central portion, there is a creation of a whirlpool and the central portion falls down. So that is a kind of a similar motion induced in the air, where all around the sides, it is undergoing a circulation. So in the central portion, automatic suction is created. Okay, and see, all of you are asking the question that how the cyclone will move under the presence of the permanent wind system. Right? How can meteorologists know which place it makes a landfall? By tracking the path of the cyclone, the path that it has taken in the past few days, and the existence of the present wind system owing to the Coriolis bending as well. That is how you take that description. Sahil, cyclone in India occurs on land also, I have seen. Fair enough. If you have seen it, Sahil, I would recommend you to file it in the science journal somewhere, because that will be the greatest discovery of all times. Till now, the understanding in all the geographical community across the globe is cyclone doesn't form over the land area. But if you have seen it firsthand, then that might be true. So please, I would urge you to file your recordings in the scientific journal. But on a serious note, it does not form over land. What you might have seen over the land area, you are confusing it with a cyclone, only tells us that you have never seen what a cyclone is. What you would have seen over the land area is, and tell me if I am correct or not, you would have seen that over some area, dust starts to rotate in a circular motion, and that is something which moves from one region to another. That is an event which we see in India most of the times during the summer season. Is it what you have seen? Yes. So who told you that is a cyclone, first of all? That is what is referred to as a dust devil. That is why I told you, that tells us that you have never seen what a cyclone looks like and how destructive that can be. What you see as small rising columns of dust in circular motion, that not even a microcyclone, that is what is referred to as dust devils. This is a common occurrence, especially in drier areas of the world, especially in the desert regions and in the areas where you have a lot of loose soil. So there, due to sudden heating throughout the day, you have a small localized low pressure, and that is what picks up the dust. Have you ever seen the formation of cumulonimbus clouds by those dust? Never. That is an occurrence restricted only to few meters. So the next time that you make such a claim that you have seen something, be doubly sure about it. Okay. And then I have a question from Amutayazini. How sinking of wind leads to low pressure formation? See, sinking of wind here, what it does is, yes, I agree that in general, sinking of air creates high pressure. But this air, as it is sinking, it is warming up. It is already a warm air, which further, as it is sinking, it will further warm up. So in a way, it is heating up the sea surface, which has the low pressure. So when that low pressure, which is already thermally induced, is further heated up, so that is what intensifies the low pressure. Okay. Impacts of dust devil, Amit, are not significant. They simply keep on moving from here and there, and you will find that after like a movement of few meters or tens or twenties of meters, they will completely dissipate. So they don't have much of an impact. Okay. Yes, Biswajit. So those of you belonging from Odisha, Andhra coastline, even Tamil Nadu coastline, even though very rarely, Bengal coastline. Bengal, not to such extent, but those of you belonging from Odisha, you would have experienced significant occurrence and repetition of these cyclones. So these are very destructive forces of nature, and these have very high amount of energy. So this is a kind of a more clearer image, a more schematic image that you can take a look at. So basically, the process is very simple. You have creation of a low pressure over the water body. That low pressure attracts winds. Now those winds are going to be moist and warm, very rich in water vapor. The winds will rise up because of the low pressure, because of the heat. So winds rise up. As the winds rise up, will lead to heating, or rather will condense, then after that will release or will latent heat around the sides, and then meanwhile condensation will also lead to cloud formation, very dense clouds. Then this will intensify low pressure, intensify the low pressure, which means more winds will be attracted, which means more moisture, As they rise up, the entire cycle is repeated. With the help of the permanent wind systems, they are carried away from one region to another. And when they make a landfall, that is when they dissipate. Okay? Now, this is about the cyclonic condition. This is how a cyclone appears. From the above space, you can see this is how the cyclone tends to appear. Many of the times, the cyclone, the clouds, they begin to form at an elevation of only 2 kilometers from the ground. But above, they can extend almost up till the tropopause. And the movement of air in many of the cases, in many of the conditions, the movement of air also induces a change in the level of tropopause as well in certain cases. Okay, so that is the feature of a tropical cyclone. Very, very destructive in power, very destructive in power. Mostly when it makes a landfall, it weakens. However, there have been certain exceptions. Exceptions, for example, you had cyclone Tote, cyclone Titli. These are exceptions. Why? Because these got stronger when they reached the ground surface. When they made landfall, they did not weaken. These cyclones didn't weaken after landfall. In fact, Tote became stronger. Why? Because in each of these cases, at that point of time when they struck the region, you already had the existence of a low pressure on the ground area. And those low pressure, they were further exaggerated by the presence of moist winds because those low pressure regions had experienced rainfall. This is sometimes something observed generally during the month of May, when you have late April, early May, when you have the cyclone season. In India, cyclone season is in April, May, sometimes rarely in June, but then again September, October, November. That is when the cyclones occur in the region of Bay of Bengal and Arabian Sea. Why? We'll discuss when we talk about the movement of ITCZ. That is what creates that low pressure over Bay of Bengal and Arabian Sea. But for example, take the case of Tote. Tote developed over the region of Bay of Bengal, Arabian Sea, around Lakshadweep. It started moving towards Maharashtra and Gujarat coastline. As it started moving, simultaneously, due to some other local reasons, you had a low pressure, significant low pressure system traveling from Haryana to Rajasthan to Gujarat, bringing rainfall along the way. So, bringing rainfall along the way means there was significant moisture on the ground as well. By the time that cyclone Taukte reached the Gujarat coastline, it had already caused flooding in Maharashtra coast and Gujarat coast. When it made landfall in Gujarat, that low pressure system which had already been in existence in Gujarat, it quickly merged with the tropical cyclone. So rather than getting weaker, that low pressure suddenly intensified and it attracted winds. And these winds, because the ground surface had received a lot of rainfall prior to it, the winds had some amount of moisture. So the cyclone strengthened itself further. It was only a state like Rajasthan which could ensure that the cyclone finally dies. So that is how sometimes in rare cases this can also happen. Okay. Now, then we come to the factor of storm surge that we have already seen in the case of temperate cyclones, but in tropical cyclones also, you will observe there is a lot of coastal flooding which happens. And this coastal flooding which happens is initiated because of very strong wind action. Very strong wind action means it is able to pick up the coastal waters and drop it more over the shoreline, over the coastline. And that is what very strong winds, which is a general feature of a stormy condition, that you have the presence of very strong winds. So here, these very strong winds, they are able to carry out surplus amount of water into the coastline. So it will lead to coastal flooding. Coastal flooding. Now, this coastal flooding, if you want to get into the depth, fair enough, you can go into it. Otherwise, for general studies, just knowing that coastal flooding happens due to the strong winds, that is more than sufficient. Due to strong winds. The other factors which lead to coastal flooding: slight rise in sea level. Why? Due to intense low pressure, then overflow of the river channels. That also brings about a flooding in those areas. Okay? Yaran Seti, when this type of cyclone appears, when forest on fire is fire to off fire, when forest on fire to off fire for used aircraft to throw water from up, can we use that planes to take water from the clouds and took that rainwater? So you are asking that when this cyclone appears, so all the cloud that is there, can we simply not scoop it out like a bucket and pour it over in case of a forest fire? I hope that is the question that you are asking. So the answer is no, because these are very dense and large clouds. Probably the airplane that you will use to scoop up the water, that airplane will crash due to heavy lightning and thunderstorms. So that is why when the heavy cyclonic winds are in appearance, you will find that those areas, they are avoided by the aircraft pilots as well. They also don't like going to those areas because there is very dense cloud. Visibility is almost zero. Within the clouds also there will be heavy rainfall. Water will keep on dropping, thunder, lightning, and you are above a water body all the meanwhile. So there is no ground underneath you. So it is very disastrous condition. Okay. Yes, Shivani, that is what coastal flooding means. No, XY, will warm air only cause only? Yes. You don't have the cold air mass in the case of a tropical cyclone. Tropical cyclone is generally caused, if we talk about the air mass, so warm maritime air mass is the one which causes this cyclone. Okay. And Nisarg, can more than one cyclone occur at the same time in the same ocean? Yes. In different parts, it can happen. In Indian Ocean, that is where the entire concept of twin cyclones come into play. We'll not go into that. Okay. Then we come to the naming of cyclone. Suparno, is that like a tsunami? Much smaller than a tsunami. Not at all as big as a tsunami. Then we come to naming of the cyclone. Now, you would have heard basically that there is different name. All of you associate with a different name of the cyclone. Ampan, Foni, Hudhud, Titli, Tote. There are different names to the cyclone. But this had not always been the norm. Prior to 1999, almost, there was a naming which was completely done on a scientific basis. Like you have the naming of the icebergs, A76, C95, like that. You had that kind of a naming system for the cyclones. Now, in 1999, something happened which made the climatologists across the world ponder about it, that why don't we fix a name for a cyclone so that we can also refer to them easily and the people can also understand clearly. So what was this event? This was the occurrence of twin attack of cyclone which happened across Odisha coastline. Those of you belonging from that region, you would be too small to recount that. But if you ask your elders what happened in Odisha in 1999, it was absolutely heart-wrenching, gut-wrenching. The kind of disaster which Odisha saw unfold in front of its very own eyes. Probably that is the reason why today the disaster relief force is the strongest in the case of Odisha government. You will find that they are the most ready and they are the ones who follow procedure to the book. They know what to do. Now, why is it? So in 1999, during the month of April and May, when the cyclone season comes in, you had a warning, and this warning was issued that a cyclonic system is developing in the region of Bay of Bengal, right? Now imagine all this while, we are in 1999. Today in 2023, if the government wants to send across a message, there are multiple avenues, social media platforms, internet, so the message reaches immediately. At that point of time, messaging and conveying of message was obviously not very convenient. And the trust level in the government, you can always imagine. So you had people from the side of the government who came in to the state and the state government also. They told the people in the coastal areas that, look, a significant cyclone is developing in the region of Bay of Bengal. It is going to strike the Odisha coastline. So better evacuate. Now, when a government personnel comes to your house and tells you to evacuate your house, what will be your first tendency? That this person has got some ulterior motive. That is why he wants me to get out of the house so that he can take all the things, he can take the house, and I will be homeless. That is the level of mistrust we have with the government. Now it has reduced slightly, but imagine what it would have been in 1999. So people did not obey. Few of them, they did obey, but most of them did not. And the government also was fair enough that, okay, I did my job. You did not evacuate. One day or a couple of days prior, when the cyclone was about to hit the land, the meteorologists, they discovered that over the region of the Bay of Bengal, the cyclone has suddenly intensified. It was observed, it was predicted that the wind speed is going to be in the range of 250 kilometer per hour. That is as destructive as it can be. Above 220 kilometer per hour wind speed, all the cyclones are categorized as super cyclones. So it was a super cyclone. That is when the government started panicking. Because till then, they had been asking people to evacuate, but people were not. And they knew that this super cyclone, which is heading towards the Odisha coastline, it will cause destruction and devastation. And it sure did. It inundated the coastline. The region around Cuttack, Puri coastline, they were completely destroyed. Cuttack was, in fact, one of those places whose face had changed after 1999. Before 1999, it was doing fairly good, but in 1999, almost everything was destroyed. And there was pools of standing water, a lot of dead bodies. It is estimated that many hundreds and few thousands of people lost their life. Now the cyclone passed away. People were busy recuperating their losses, finding their lost ones, finding their family members, collecting the dead bodies, collecting the dead cattle. As this was going on, within a couple of days, Indian Meteorological Department, now while this was going on, the entire country swooped down upon the government that you did not provide us with a warning. It was your duty to give us warning, you did not. So you failed us. Fair enough. Within a couple of days, as this cleaning up exercise was going on, many areas were still flooded. Indian Meteorological Department detected that there is another low pressure system developing into a cyclone in the region of Bay of Bengal, and that is also going to make a landfall in the same area around Odisha coastline. So this time a fresh warning was issued, and this time it was ensured that this message goes through. People are made aware of the fact that a cyclone is coming through. But then the response from the side of the public was that the cyclone has come, it has impacted us, and now you are coming to inform us. Because public generally thinks that it is the government who has a delayed action. They are much late, the cyclone has come and went by. Little did they realize that the government officials were warning of another cyclone within a week. And this time, many people were caught unawares. The second cyclone struck, and the area was completely destroyed. Many people who were left out in the open lost their lives. In fact, till today, if you talk about unofficial figures, people from that region, they still vouch for the fact that close to around 15 to 20,000 people lost their life within a matter of 10 days due to the twin cyclones. Given the fact that Odisha as a state, particularly at that point of time, was not very well in terms of social indicators, you had a lot of poor sections of the public who lost their lives. Now, this was a lesson to everyone, especially in the region of Indian Ocean, where a lot of these cyclones occur. When people, they started investigating, analyzing that why such massive loss of life occurred, one of the reasons which was found was that people got confused that which cyclone are they being warned about. Then germinated the idea that if we provide a kind of a name to the cyclones, maybe it will be easier on the part of the people to associate with it, to relate with it. So in the year around 2000, you had 8 countries in the Indian Ocean region, the North Indian Ocean region, that is in the region of Arabian Sea, Bay of Bengal. 8 countries, they got together under the aegis of World Meteorological Organization. 8 countries in 2000, 8 countries, they submitted 8 names each. So in total, how many names do you have? You have 64 names. Countries were arranged in alphabetical order. Countries, they were arranged in alphabetical order. And the names that they had given, that was arranged in the column next to them, like that. Country B's name, etc. And this is how the naming procedure started. One by one, a name was picked up from the list, and a cyclone which would impact either the Bay of Bengal or the Arabian Sea, that name was allocated. Another cyclone, if it is getting formed, another name was picked up. So that is how alphabetically names were picked up. The last name on that list, last, was Cyclone Amphan. This was given by Thailand. Thailand had given this name. So this cyclone Amphan developed in the region of Bay of Bengal, and in the later April and first week of May, it developed into a super cyclone again. It made its landfall in the region of West Bengal and dissipated by the time it reached the region of Bangladesh. Now, this Amphan was the last name, and this was used when? This was used in May 2020. So everyone was aware that in 2020 the names can get exhausted. Maybe by 2019 the names can get exhausted. So this 64 names lasted for almost 20 years. These 64 names. They lasted for 20 years. So in 2018 itself, prior to the pandemic, all these countries, the 8 countries, they got together that we need to come up with a new name list. But this time, 5 more countries in the Indian Ocean region, they also got together. So now you had 13 countries. So now you had 13 countries. All of them gave 13 names. So what is the total number of names that we have? 169 names. Right? Now, we have a total of 169 names. So one by one, from that list, name is picked up. Whenever a cyclone is formed in the region of either of the Bay of Bengal or Arabian Sea, a name is picked up. So that is how the entire process came into existence, and that is how the naming is done. Let us get into the intricacies of it. So you have 2 major organizations or bodies which are responsible for the naming. One is, and the most important is, the RSMC, that is the Regional Specialized Meteorological Centers. You have 6 RSMCs across the globe to look into the weather conditions of different oceanic region. And you have the TCWC, that is the Tropical Cyclone Warning Center. So initially, when a low pressure starts getting formed over a water body, this issues a warning. Issues a warning. As it develops into a cyclone, that is conveyed to the RSMC, and RSMC, based on that naming list, picks up a name and gives that name. So these are the typical RSMCs across the world. For example, RSMC Miami in Florida is responsible for naming of the hurricanes which occur, right? RSMC Honolulu, that takes care of the eastern portion of Pacific. RSMC Tokyo takes care of the naming of the typhoons which develop in South China Sea and so on. RSMC New Delhi is the one which is responsible for naming of the cyclones formed over Arabian Sea or Bay of Bengal. In the southern Indian Ocean, you have RSMC at Reunion Island, which is basically taken care by the French meteorological government, French meteorological department to be more precise. And you have in South Pacific, RSMC Nadi. These are the RSMCs. So here you find the list of the countries who have given the name. So these are under the aegis of World Meteorological Organization. Observe that the countries are arranged in alphabetical order. This is just the 2 columns that I have given you. There are more, in total 13 columns. Each of the countries, the names that they have given, that is affixed in the column in front of them. So for example, Bangladesh has given Nisarg, Biparjoy, etc. India has given Gati, Tej, and so on. Right? So that is how the naming is done. So how is it that the name is picked up? One by one in this list, you pick up the name. So what was the last cyclone which occurred? The last cyclone occurring in the region of Arabian Sea or Bay of Bengal, what was the name of that cyclone? Very good. Ananya, after that, a couple of more cyclones have occurred. So the last was Mandus, as it was referred to. This was given by UAE. Now, the next, before that you had Sitrang, before that you had Asani, before that Jawad. Now, the next cyclone which will occur, be it in Arabian Sea or Bay of Bengal, it will occur or it will be named as Mocha. Now, after that, the next cyclone which will occur, be it in Arabian Sea or Bay of Bengal, it will be referred to as Biparjoy. After that, Tej. After that, Hamoon. After that, Midli. Like that, this list will be taken. After that, another list from here. Right? So this has come into presence, or this naming has come into prominence after the second half of 2020. Okay? Now, let me check something. How many of you feel that it is important to learn the names on the list? Good. Very good. Please do not learn the name on this list. Whenever you find such lists, please never learn this. One or two examples will be more than sufficient. Please don't learn this. Nobody is going to ask you, describe the names of this cyclone. No. So please don't try to learn this. Okay? Right? Last one, though, obviously you will remember based upon the current affairs. By the time that you are appearing for the examination, the last one will always be there in your mind. That is the least expectation that I'm having out of you. Now, this is the tabulated difference between a tropical and a temperate cyclone. So, tropical cyclones move from east to west under the influence of the trade winds and the easterlies. Temperate cyclones move from west to east. Tropical cyclone has an effect on comparatively smaller area with a diameter of around 500 kilometers or so. Temperate cyclone affects a much larger area, right? Then the velocity of wind in a tropical cyclone is much higher and it is more damaging. It is comparatively lower and it forms only over water bodies. It can be formed both over land and water bodies. And a tropical cyclone doesn't last for more than 7 days. Temperate one can last for 15 to 20 days. So that is how you have these cyclones. UPSC has asked this question in mains and in prelims multiple times in various different types of MCQs as well as direct a question. How is it that the cyclones are named? This question has been repeated. How is it that the tropical cyclones are formed? This question has also been repeated. Why is it that certain regions of the world they experience more tropical cyclones? How is it that the tropical cyclones are formed? What is the difference between a temperate and a tropical cyclone? These kinds of questions are always asked. So overall, the effect of air masses on climate, if you take a look at it, what are the effects of air masses on climate? They can always induce a temperature change. They can bring about a rainfall when we talk about the maritime air masses and so on. They can lead to creation of different types of fronts, right? Different types of fronts can be created as a result of this. Okay. Now, these are few of the questions which have been asked in the mains examination, right? So, for example, discuss the concept of air mass and explain its role in macroclimatic changes. So, in this, what do you write? Concept of air mass. So what is an air mass, right? What is a source region? That is something you will write in introduction itself. Role in macroclimatic changes. So what is it, the impact that the air mass has on climatic conditions? So you can talk about increase or decrease in temperature depending upon the warm or the colder air mass coming into an area. Maritime air mass brings rainfall. Cold and warm air mass, when they meet, they create different types of front. In the case of a cold front, they create these conditions. Warm front, such conditions. They can lead to occurrence of cyclones. Warm maritime air mass can lead to the tropical cyclone. Cold air masses can lead to temperate cyclone. So all this you can write. Okay. Then tropical cyclones are largely confined to South China Sea, Bay of Bengal, and Gulf of Mexico. Why? So broadly, if I tell you that it is because of increased warming that these areas receive, but that is something which will not satisfy your appetite. So I would suggest you to wait till we complete the portion of oceanography, that is study of the oceans as well. Then we will be better placed to answer this question. So we'll ignore this question as of now. The recent cyclone on the east coast of India was called Phelan. How are the tropical cyclones named across the world? So this is a question which was asked, I guess, in 2013 or 14. That time Phelan had happened. Phelan was a name from the blast list. That is why it was asked. It is not as if now UPSC will tell you that, okay, fair enough. Do you know naming of cyclones? Okay, but we are searching for very intelligent guys. So you tell me about the cyclones and the names prior to 2019. UPSC does not ask you such questions. So please don't go out searching for the older names just because you want to hear about a name of a particular cyclone. Please don't do that. Okay, well, your time is very, very precious. Then bring out the causes for the formation of heat islands in the urban habitat of the world. This is about urban heat island. So in the introduction, talk about it, that in the urban area, there is a sudden spike in temperature as compared to the hinterland, rural areas, and the forested region. This is the impact referred to as a urban heat island effect. The impact of the reasons for the urban heat island are: talk about the reasons. We have given the reasons in the PPT itself. Talk about it. Explain each of these in a couple of sentences, 3 to 4 sentences, and that would be sufficient. What do you understand by the phenomena of temperature inversion in meteorology? How does it affect the weather and the inhabitants of the place? So temperature inversion, the types of temperature inversion, what are the conditions and the weather conditions created on the ground surface? Talk about it. How do they affect the inhabitants? So they bring about or they do not lead to mixing of the air, so the pollutants remain in the air for a long period of time. In the case of valley inversion, the valley bottom suddenly becomes very cold, leading to the death of the plants as well in that region. So all these factors you can talk about. All these you can try writing on your own as well. Other than the second question, I would advise leave this question as of now. Write it after Tuesday, when we would have done the portion of oceanography significantly. After that, you do it. Till then, the other 4 questions you can try writing on your own. Okay, all those who do seek the practice questions regularly, I would suggest you to write it on your own. Okay, get it evaluated. And as of now, when you are writing answers, please don't have the aim that out of 15, why am I not given 15? Nobody's going to give you that. Have a very basic aim that at least 50% marks I should get. And right now, your effort and endeavor should be to look at the comments that the evaluator has given and to improve on the comments. The easiest reaction from a candidate, always the easiest reaction from the candidate is that the evaluator has not understood what I tried to write. That is why I have gotten less marks. If I would have had a better evaluator, I would have scored better marks. You ask a student who is in class 3, he or she will also give you the same answer. You ask a student in class 5, he or she will also give you the same answer. You ask a student in board exams, they will also tell you that, I had written an answer better than my friend, but my friend got more marks because the evaluator was better. And I have proof as well. The same logic you will apply here as well. But you are appearing for UPSC mains examination. I hope the aim is still the same. There, you will not even know where your copy has been evaluated, right? So all the grievances that you might have, even the court does not entertain that. And it is not a matter of the board exams where you park $600 in an envelope and send it for re-evaluation. Might be you receive a 5 marks bump. That is not the case in UPSC. So that is where you have to train yourself upon the whims and fantasies of the evaluators from now itself. Okay. Now, uh, then so much energy is released. Can't we use this energy to generate electricity? See, XY, the thought is very novel, I must say. And there are multiple projects running across the world as we speak, where people are trying to trap the light energy released by lightning. But the problem in these cases is that these are such violent systems. We don't have enough capacity to bring them under control, right? Even in the case of the tropical cyclones, when they develop over sea, that region is absolutely a place where you cannot go. If you go, chances are that your measuring station itself will be destroyed. So that is where captivating such large natural, it is going to be the energy of the future. Maybe 50 years down the line, we develop a technology which can trap electricity from lightning. But as of now, we don't have it, right? Now, Pratyaksh, if you are getting 6.5 on an average, do one thing, start encapsulating your points that you are trying to convey in a bullet point, sub paragraph, underline it, write a couple of sentences that you have to draw more images. It will always help you. Okay. Now we come to atmospheric phenomena. Again, this is something very, very relevant for your exams. In this portion, what is it that we are going to study? We are going to study ENSO cycles, that is El Nino, La Nina, then before that we are going to study Walker circulation as well. What is a Walker circulation? Then we are going to study Indian Ocean Dipole, Then we are going to study something which you don't find in the books generally, oscillation. Then we'll talk about jet streams. Right? Here, these are going to be relevant for your prelims. And for mains, relevance is going to be there for jet streams, and basics of ENSO cycle. Nandamuri, is economics and geography easy to score mains marks as compared to history and polity? See, first of all, it is not a common trend, Nandamuri, but the subject is such. When we talk about paper 1, generally you will find in paper 2, people on an average, they score less. And that is because of the factor that all of you, if I ask everyone who is present here, that for polity, which is the book that you are referring to, you will have only one book in your mind, isn't it, more or less? You will have the book of M. Lakshmikant. Do the same exercise for the entire country of all the people who are appearing for the civil services. All of them, they read the same book. And all of them, they find that particular subject to be such enticing, and in a way, it has a unitary reward system as well, that you read these many topics, you will get these many questions. So everybody has got the same level of preparation in polity. It is a different matter that while you are a candidate, you feel that how I have understood polity, that is to the next level. So that is why polity and governance, in general, they are not very rewarding. You'll find your marks, if you have given a good exam, you'll find roughly around 95 to 100 in certain years that you will get in paper 2. Paper 3, when it comes to, when you talk about economics, environment, ecology, etc., there sometimes you find the paper to be twisted in the terms that certain questions appear which nobody will know. Maybe one or two people know, but that hardly creates a difference. So that is where paper 3 again is lower on the average. Paper 1, history and geography and society. Society, everybody is able to answer. There is no issue in that. Then comes history and geography. Total 250 marks. Geography is 105 marks out of 250. Now, geography is always going to be more rewarding as compared to history, always. Because in geography, the questions that appear, many of them, you don't need the books to answer. Your own understanding that what is the problem with urban India, what is the problem in rural India, that in itself will help you answer this. What is the problem with water scarcity back home? All this you are able to answer on your own. So in this 105 marks, your effort should be to get at least around in the range of 60 to 65. Then overall in paper 1, you are able to cross that figure of magical, for paper 1, that magical figure is around 110. If you cross that, fair enough. That means if you are able to, because in history also, keep yourself mentally prepared for that, that in history also you will find a couple of questions which you have never even heard about, or a terminology that you might have read about, let's say Guptas, or you might have read about Rashtrakutas, but you have not heard about that terminology that has been asked. So that is why most of the candidates will falter, many of them falter in that as well. So overall in paper 1, that is why if you have studied this subject carefully, the subject of history, geography, if you have studied it carefully and not only restricted yourself to a certain area, you have broadened your understanding, then always you will be able to score significantly good. This can be a difference creator along with your ethics and optional. Okay. And Kiran, your question also I had to take. This was a long question that my concern is that if I'm going through any current affairs and in that topic there are 2 or more points which has a linking with other topics and other news too, it becomes so difficult to cover all that. So don't worry about it. As of now, just keep on reading those current affairs. Be very, very regular with the current affairs. Revise it with the help of the monthly magazine. There you will find those implications which are present. Right now, you have the same feeling which most of the candidates have at the preparation. That is the FOMO factor, fear of missing out, where the candidate feels that if I don't read this sentence, that is why I won't get through civil services. So shed that FOMO factor, study what you can, revise it. The key to success is only 2: discipline and revision. If you manage these 2, you will clear the exam. As simple as that. Okay. Now, what monthly magazine? Any monthly magazine that you like, whichever monthly magazine that you like, read that, but stick to the same magazine. Not that few of my friends are reading something else, so I'll study something else. The other friends are reading something else, I'll study. No. Any monthly magazine that you follow it through and through. Okay? Yes, Nitesh, absolutely. Then we come to rise and fall of air parcel, which will help us understand the processes of Walker circulation and so on. So here, when we talk about it, till now, what is it that we have seen? We have seen that when it comes to thermally induced pressure regions, which are created across the planet, till now we have seen basically, if this is the planet, we have come across a scenario or a situation where you have a low pressure system at around the region of equator, a subsequent high pressure system at the region around 30 degrees, a subsequent low pressure region at around 60 degrees, and another high pressure system at the region of the poles. So we have an induction or a kind of a circulation which is happening in between the different latitudes. Isn't it? This is what we have seen in the tricellular model. So till now, we have seen that air tends to move, air tends to circulate in between various different latitudes. We have seen that. Now, this air which circulates in between the latitudes, why does it circulate? Because of different pressure. Now here, you had a very famed meteorologist or climatologist of his times, that is in the late 1800s and in the early 1900s, with the name of Sir Gilbert Walker. Now, Sir Gilbert Walker, you can refer to him as Gilbert Walker, you can refer to him as Gilbert, you can refer to him as Walker. So please don't get offended when I use the term Sir. So Gilbert Walker, basically, he was very interested in finding out that across the planet there are multiple such circulations that we don't know about. And Gilbert Walker, when he observed the region of the Pacific Ocean, he observed something very unique. Because the Pacific was so large, it is the largest ocean. Because the Pacific is so large, there is different rate of heating and cooling received at both ends of the Pacific. And Gilbert Walker was so very sure that this difference in temperature at both ends of the Pacific, that will induce a circulation across the Pacific. A circulation which might not happen between different latitudes, a circulation which will happen across the same latitude. It will rise up in the upper atmosphere, and this circulation will happen across two ends of the Pacific. He was also certain that one of the most complex climatic conditions across the planet, one of the most complex climatic phenomena across the planet, that is the Indian monsoon system. Walker was convinced that this also has an impact on the monsoon system. And for that, it is said, it is only because of that, that he got himself posted in the Indian Meteorological Department. At the time when you had Lord Curzon as the viceroy in a form. So in the early 1900s, at that point of time, Sir Gilbert Walker was the head of the Indian Meteorological Department. Even though he could not make a certain study that how this Walker circulation could influence the Indian monsoon. But nonetheless, he was the first one who observed that both ends of the Pacific, they will get heated at a different rate. And because they will get heated at a different rate, they will develop a competing pressure regions at both of these ends. And because of these competing pressure regions, they will initiate a circulation amongst themselves. And that is what he named as Walker circulation. So let us try to understand what is it that Gilbert Walker talked about. So first of all, here, let's say we draw the equator first. Okay, let's suppose we draw the equator here. Now, tell me things one by one. We'll arrive at the conclusion one by one. So here, around the region of equator, we have a very large water body, that is the Pacific Ocean. Now, I understand we have not studied oceanography till now, but the basics of oceanography, I'm sure all of us would be aware. When I consider an oceanic water which has got depth, and underneath you have the crustal portion, etc. First of all, what is the prime source of heat for this oceanic water? Where do you think this oceanic water receives its main heat from? What do you think? It is from the sun. Khushi, kindly ask your question once again. I will answer it after the class. So it is the sun. So sun is the main source of heat. This is the main source of heat, which is heating the water body. Now, where is it that intensity of sunlight will be greater, here at A or here at B at a depth of 20 meters? Where is it that the intensity of this insolation will be greater? Obviously at A. So the temperature will also be greater at A. So A will be the warmest layer, and B will be the cooler layer. Now here, in case, let's suppose, over the water body, let me draw the water body here again. Over the water body, let's suppose you have movement of wind. Very strong movement of wind. So that wind overall, slowly but steadily, will be able to carry some amount of surface water along with it, isn't it? Now, when the surface water will be carried by the wind, do you think the depth or the ocean level will start reducing? Or do you think the lower layers will come up and replace it? Obviously, ocean level will not reduce. As the surface water is carried by the strong winds, the lower layers come to the surface, isn't it? So, when the wind blows across, can we not say that strong winds, they carry the heated surface water and at the same time expose the cooler waters underneath? We can say that. Let's use that to understand this circulation. So first basic, strong surface winds carry the surface water heated surface water the subsurface water is then exposed and it lowers the temperature. Lowers the temperature. Fair enough. Now let us take a look at this map again. Let us return to this map. Now, we have seen the region of equator. Around the equator, what are the winds which move? Which are the prevalent winds around equator? Let me know. Beautiful. Only one kind of wind system exists around the region of equator, and that is the trade winds, isn't it? Now, what is the direction of the trade winds? Trade winds move like this in northern and the southern hemisphere. They move like this in the northern and the southern hemisphere. Now, rather than looking at where the winds are originating and what their motion is going to be, let us concentrate our attention only to the region around the equator. If I were to look at the direction of the winds at the region of equator, can I not say that the general wind direction is from west to east at equator? Can I say that? General from east to west. Wind direction at equator is east to west due to these trade winds. Now, these winds are consistently moving over the oceanic area. Frictional force is less, so the winds tend to get stronger. When the winds will get stronger, they will pick up more water along with it. They will be able to drag more water along with it. Surface water which is warmer, that will be dragged, isn't it? Now, in this case, the surface warm water from all these areas that is dragged, and eventually that warm water accumulates here. Accumulated surface water, which is warm. Now, this is the accumulated surface water. At the same time, as the surface water is being carried away, the subsurface water will expose itself. The surface water, as you remove it, the subsurface water will expose itself. Subsurface water is cooler. So what can we say about the temperature of the water body in this area? What can we say about the temperature of the water body in this area? It will be comparatively, it will be cooler. If not cold, comparatively, at least it will be cooler, isn't it? So you have the cooler subsurface water. Now, across the both ends of the Pacific, in one place, you have the accumulated warm water. In other place, you have the subsurface water, the cooler water, which is now exposed. So there will be a competing pressure difference which will be generated. What will be the pressure difference of pressure generated here? Where you have warm water which is accumulated, what is the kind of pressure generated here? Very good. You have low pressure. Deepika, as the sun is consistently providing the heat, so why the water will be cooler? But at the same time, the wind is dragging the warm water on the surface consistently as well. So that is why consistently subsurface water is coming up, isn't it? We will study about this in upwelling in the next class. Here you have low pressure. In this region, what do you have? Comparative high pressure, isn't it? Winds always blow from a high to a low. So that will start to generate a wind movement. A wind movement will be generated. Which color do I use? Let me use this color. Wind movement. In fact, these trade winds themselves, they will reorient their direction, and rather than northeast to southwest or southeast to northwest, they will take a east to west direction. And these winds, when they reach this low pressure, what will happen? These winds will also warm up. They will rise up. So as the winds are rising up, there will be condensation. The winds will be attracted from other direction as well. As they rise up, they will lead to formation of clouds. This region will receive very heavy rainfall, intense rainfall. The wind rises up. The wind is rising up, guys. Please don't confuse that he's saying wind is going to Japan. No, it is rising up. It is not going north, it is rising up. Eventually, at tropopause, it will diverge. It will sink around the region of that high pressure. And this circulation which is achieved, this circulation is not happening between different latitudes. It is happening across the same latitude. That is a circulation which is referred to as a Walker circulation. So overall, if you take a look at what this Walker circulation is, very briefly, trade winds blow from a general direction of east to west. That leads to the winds blowing over a vast expanse of Pacific gain a higher speed because there is less force of friction. These trade winds tend to drag some amount of surface water along with them, as a result of which these surface waters, they are warmer due to higher solar insolation. Surface waters are always warmer. As these warmer waters accumulate, that creates a condition of low pressure in one region of the Pacific. And that is the condition that you observe, where around that low pressure that is across the Australian coastline, you will observe the formation of convective clouds, thunderstorm, lightning, etc. Whereas across the Peruvian coastline or the South American coastline, you'll find dry and fair weather conditions. WX here refers to weather. This is weather condition. So this is what is referred to as a Walker circulation. This happens across the region of equatorial Pacific. So when we say a Walker circulation, the longitudinal circulation across the equatorial Pacific is known as the Walker cell or the Walker circulation. Okay, it is this Walker circulation which strengthens to form La Nina condition. It reverses to form El Nino condition. So we'll study that in the next session next week on Monday. Till that point of time, have a good weekend. Relax on this weekend. I hope this session was meaningful. Next Monday, we will meet. We will build upon these concepts. So I urge you, please take out some time to revise this portion. Understanding will be much easier as well. And tomorrow, the test shall be uploaded. Objective questions, 20 objective questions, 5 subjective questions. Objective questions, at least give it a try. Please don't look into it that how much marks you are scoring. That is immaterial at this stage of preparation. Even if you score 0, fair enough, as long as you take some learning out of it. You get to know that which areas you have to concentrate more. Okay, so that is where we'll restrict the session for today. A couple of questions I will try to answer. Uh, right. Why are temperate cyclones becoming less common with climate change? Vaishna, good question. That is because now even the polar air is warming up. So that is why the difference in temperature, which is essential for the creation of a front, that in itself is dissipating. Payal, velocity portion V1, V2 need to be similar to form a tropical cyclone so that the upper wind does not carry away all the cloud formation, so that heat which is generated, it is maintained in a region. Okay. Then tornado and a cyclone. Tornado is generally formed over the regions around United States in the large land areas. Tornadoes, they don't form over the water body. So there you have, in the presence of cumulonimbus clouds, you have a sinking air which mixes with the cold air. So the sinking air becomes warm and the cold air at the bottom starts circulating around the low pressure, and that is where what generates an eddy in that region which joins with the cloud as well. So that is what is a tornado. It is very different from a cyclone. It will have much greater wind speed. Tornadoes will have much greater wind speeds. Okay. Gagan, as the DM of Cuttack, what could be my reaction if people are not listening? So in that case, ideally, you should make them aware of the consequences and the disasters which the cyclone has the potential to cause, right? And also, you can give them assurances that if you feel unsafe leaving your house, you will have the government who is responsible for your house, your belongings, etc. You can give these kinds of assurances. How to write conclusions in geography, Devansh? Just the basic ones, the technical questions that you have, for example, impact of air masses on climate. So when you are writing the conclusion, you have to summarize. So overall, air masses have a distinct impact on climatic conditions, which in turn influences the life habits, the fooding habits, the clothing patterns, etc., across the globe. More needs to be understood in this regard to have a clearer picture. So that is how you conclude it. If you have a kind of a question for water scarcity, for example, let's say urban issues in India, so there you can provide a kind of a way forward in the conclusion, but for the physical geography, conclusion has to be and needs to be technical. Biswajit, 6, 8 and 10 degree channels, these are the water bodies separating different areas. So this is basically named after the 8-degree latitude, the 10-degree latitude, the 6-degree latitude, which passes. So for example, 10-degree latitude is famous for what? For separation of, or providing a separation of Andaman and Nicobar group of islands. Okay. Is this a question? Is this a slide XY? Priyanka, yes. Along with the portion of current affairs and the class videos, more than enough. No, Gagan, these are referred to as the longitudinal circulation. Pratyaksh will talk about it on Monday. Okay. Walker circulation occurs only in equatorial Pacific region, yes, but it has its implication across the globe, Shamil. Is the name of the cyclone is given based upon the area that it occurs? Sukanya, no. For example, the Northern Indian Ocean, you have those 169 names. So regardless of whether a cyclone is formed in Arabian Sea or Bay of Bengal, a name will be picked up from that list. Devansh, cyclones have no relation with day and night? Absolutely not. In objective test, I'm getting 8 to 9 correct and rest incorrect. So don't worry. Try to learn from what you have done incorrect. Failure is another path to success. So try to learn from all those mistakes that you have done and ensure that next time you don't commit that mistake. Okay. Right. No, Yaram City. It was a kind of an isolated event that in Andhra Pradesh you are talking about. That was because of isolated heating, the heat wave conditions which have been prevalent, particularly in the Deccan region of the country. That is what resulted in that. So it was an isolated event. Slavat, we will remind me once on Monday. I'll pick up a question and I'll talk about it. How air sinks in the high pressure. So here, when you have the high pressure region, high pressure already means the sinking air in this area, and the air is generated. So there is a movement already. So there is a kind of a suction created from above. There's a kind of a gap created from above all the way up till tropopause. That is where the air starts channelizing itself. Okay. And Indian Ocean naming system, that is what you have to read, Ravi. Mupkalvar, naming of cyclones for the rest of the world, each of the RSMCs, they have their own mechanism. For example, the RSMC in Florida ran out of the names to name the cyclones last year because so many cyclones occurred with greater frequency. So they resorted to naming as a Greek alphabet, cyclone alpha, cyclone beta, theta, gamma. So that is how the naming is done. So it is different for all the RSMCs which are present. Okay. So that will be all from my side, students. So all of your questions which are still unanswered, don't worry, our SMEs are going to get back at you. If not, write to us. You can write to me. We'll get back to you. We'll meet on Monday. Take care of yourself. Goodbye. Thank you and have a good weekend.